Hey guys, this is lecture video 8 of CSE2000Q2S, Computer Science 2, taught by Lawrence Orijuela, and my name is Lawrence Orijuela. Today is October 23rd, 2020, and today we're going to discuss class inheritance, which is actually one of my favorite features of C++. So let's get started. So once again, this is our tentative schedule here. So today's October 23rd. We are discussing inheritance, and the activity for this lecture video is going to be due next week, activity 7, and you have 2 items due tonight. The first one is your activity 6, which discusses structs and classes and constructors for both. So make sure you turn that in before midnight tonight. And the other one is your midterm exam. Okay. So as we agreed, I've decided to give you an extra week to do the midterm exam because this is my first time teaching this class, and I don't know how well it's gonna play out, but I do hope that I was lenient enough for you guys. I mean, after all, I've given you 2 weeks for it, and not only that, I've given you the solution for one of the questions, question 2, and on top of that, I'm also dropping your worst question. And on top of that, in the back of the test, there is an extra credit question that involves no coding and just writing sentences. That's worth 10 points. That's an entire letter grade. Okay? So, I like to think that I've been extremely generous with the midterm exam. And also, I haven't been getting that many questions on my email in regards to, like, the midterm exam. That could be a good thing or a bad thing. It could be a good thing because it could mean that this test is so easy that you don't need help. Or it could be a bad thing because maybe the test is hard and you're just give up on it. I really hope it's not the latter. But anyways, yeah, so please get activity 6 in your midterm exam to my email before midnight tonight. And without any further ado, let's talk about inheritance. So here's the little disclaimer again. I've showed this in the last 2 videos discussing what we're going to be doing. So yeah, once more, due to time constraints, lecture activity 6 through 8 and lab 3 will build on top of each other. And to reiterate, the only reason why we're doing it like that is because classes, as powerful as they are, they take a long time to write. Okay. Well, anyways, we are on week 9 right now, and we are going to do inheritance, and this is what we'll be doing today. We're going to write 2 new classes called studentType.h and FacultyType.h that inherit from PersonType.h. Okay. And then the week after that, we're going to talk about operator overloading, which is also a feature of classes, where we're going to write overload functions for studentType.h and FacultyType.h, okay? So, and again, we will take these 3 classes that we wrote in lecture activities 6 through 8 and add them to our lab 3, and that'll be it. So, inheritance. It would be useful if we looked at lab 3 again and reminded ourselves of what it is that we're trying to do. So I'm gonna exit real fast and pull up lab 3 on my second monitor. Okay, here we go. So I will put this right here. I'll make this bigger so you can see it. Okay. So this lab covers the following: classes, inheritance, and overloading. Your main.cpp is already written for you. Yep, I wrote it. And here's what we're trying to do. This program simulates a school database that stores information of students and faculty. To finish this lab, we must do the following. Add 2 new text files to the program named faculty.txt and students.txt, and you'll find these text files on Blackboard. They're right over here. Here's your faculty type, your faculty.txt and your student.txt. I completely made this data up, by the way. Okay. and then add 3 header files called persontype.h, studenttype.h, and facultytype.h that we finish/will finish by the time you complete lecture activity 8. And then 3, run the program and play with it, see how it works, and then take a screenshot. Okay? So, now I know this looks intimidating, but it's really not. You're just adding 2 text files and 3 header files, okay? But, that's what you need to do to complete it. I kind of glazed over what it is this lab's trying to do. Well, actually, you do know what this lab's trying to do. I'm trying to demonstrate to you how powerful classes and inheritance and overloading is, okay? So, back to this. So, consider Lab 3. It's a school database program. We already know that. So to complete it, we need to create 2 classes. Well, we're actually writing 3, but I'll get to that in a little bit. So the 2 main classes are student type, which is an object that will hold information of a student, and faculty type, which is an object that will hold the information of a faculty member. Now, I drew 2 diagrams here called student type and faculty type, and inside of these boxes, I wrote the private variables that's going to be included in both these classes. So student type has 6, okay? First name, last name, age, student ID, major, and GPA, okay? The private variables of the faculty type class is first name, last name, age, discipline, which is the subject that this particular professor teaches. It could be math, English, chemistry, so on. And salary, which is how much this professor is getting paid, okay? Now, obviously, faculty members don't have a student ID or a major or a GPA, and obviously, students don't have a discipline or a salary, okay? So, the requirements are shown in these diagrams, okay? So, these are the 2 main classes that Lab 3 will use, okay? Now, at this point in time, you could be asking yourself, why did we create a class called person type? It doesn't appear to be used in this program, and if you actually look back at Lab 3, you're actually right. Like, so, if you could kind of make sense of this code, there actually exists 2 vectors. There are 2 vectors, one of student type called students, and one of faculty type called faculty. And there is no vector for person type because we don't use it. Well, you might think that, but you'll see that that's not really the case. So, yeah. Why did we create a class called person type? It doesn't appear to be used in this program. Well, to answer that question, we have to talk about a couple things. So, if you look closely, student and faculty share 3 common private variables. First name, last name, and age, okay? Because you know that the student has a first name and last name and age. You know that the faculty has a first name, last name, and age, okay? Now, if we didn't know what inheritance is, and at this point in time, you guys don't, but I do, we would have to write the exact same member variables and the exact same setter and getter functions for both of these classes, okay? Now, that's kind of a pain to do, to have to write the exact same code over and over for these 2 different classes. Now, it might not seem like that much of a task for, this particular program because it's just 2 classes, all right? But imagine one day you're working as a software engineer for a really big company, okay? You'd probably have to write a program that's much larger than what you're seeing in our Lab 3, right? Yeah, this is our Lab 3. Now, so you might be asked to write a program that could have dozens or even hundreds of different classes, okay? And many of these classes would have the exact same situation here where there's shared variables. Like, yeah, many classes could contain the exact same members, okay? you'd think that you need to copy the exact same code for all the share members of all of the different classes that you're writing. Now, that's a really big pain to do, to have to write first name, last name, age, and then the setter functions and the getter functions over and over again for each different class you're writing. So, you have to stop and ask yourself, isn't there a better way to write large programs like this? And the answer is yes. And the answer to that question is inheritance. Okay? So, I just love inheritance because it's such a powerful feature of classes. So, inheritance allows us to create new classes from existing classes. Okay? Over here is our personType.h class that we wrote before. Well, in a diagram, of course. Now, the new classes that are derived from existing classes are called derived classes. That's a vocabulary word that you need to remember. And then the class that is being derived from is called the base class. Okay? Derived classes contain all of the class member variables / functions of the base class that it's deriving from. How cool is that? Okay? So if we have a class named personType.h, we can have student type and faculty type inherit from that, and because of that, we only need to write the variables and setter and getter functions for first name, last name, and age once. That's powerful. That saves us a lot of time and a lot of coding. Okay? Now, little note on the bottom, structs cannot inherit. Okay? So, one day when you're working as a software engineer and you have to think of like ways in which you want to contain your information, you have a choice. You can either use a struct or a class, okay? Now, you can use structs for simple things, but because structs cannot inherit, you would probably want to write classes for much more complicated things, okay? So that's just something that you should keep in mind if you're working as a programmer one day, like which one you should use, okay? The same way you got to think about whether or not you want to use an array or a vector, right? So as you code more and more, you're going to start thinking more like a programmer, okay? So moving on. So this is why you were asked to create a class called personType. Even though it's not directly used by our Lab 3, student type and faculty type will inherit from it, okay? So as you can see in this diagram here, person type is our base class, and then student type and faculty type are our derived classes, okay? So inheritance, I love it. Super powerful, especially for very large programs, okay? Now another nice key feature of inheritance is that it allows for sizability, because we have this base class here, we can write even more derived classes that inherit from this base class, okay? So imagine, now I completely made these examples up. Imagine you wanted to extend the features of your Lab 3, the school database program, and create a class called employee type, okay? Now, this would probably be the kind of class that you would use for people who are neither students nor faculty. Maybe they're like janitors or the HR or whoever. They would probably have like a new private variable called, I don't know, job or something, where it says what they are, like the janitor or IT or HR or whatever. Okay? So you could easily inherit from person type because they are going to have a first name, last name, and age, right? That's guaranteed. Because there's no person out there that doesn't have a first name or a last name or an age, right? And you can inherit that, and you can easily add that to a program, okay? So that helps with sizability. And another example that I wrote here is, imagine you wanted to create a new class called Master's Student Type. So, so this new class, like if I asked you to write this, it would inherit from student type, right? It would contain every private member that student type has, with its own private members of its own. Maybe it contains like, of course it would contain all of this, but one other variable that it could probably contain is probably, like project advisor, or yeah, project advisor, because I'm a master's student and I have a project advisor, and that's Professor Gomez, right? Undergraduate students don't have project advisors, but anyways, so yeah, that's sizability for you. So to use inheritance properly, you would need to think of your classes in the form of a hierarchy tree. And I actually wrote a couple examples here. Now, these examples that I wrote, I completely made them up. But I'm showing it to you because it's time that we got to start thinking like programmers here, all right? So take a look at this first diagram. Like, the way I picture this, like, imagine that you're writing this physics engine or this game that utilizes a bunch of different shapes, okay? Now, shapes, depending on what they are, they can have all sorts of different private members, okay? But the way that I would go about writing classes for each different shape is that I would have a base class called shape, and then I'd have two-dimensional shapes inheriting from class shape, okay? Now, each one of these shapes could have different, like, private members of their own. Like, circle could have radius, area, and rectangle could have length and width. Triangle would have base and height, right? And then you would have, logically speaking, you would have sphere inherit from circle, okay? Now, sphere has some variables that circle does not. Like, for instance, one of them is surface area and volume, because 2D shapes don't have volume, right? And then another 2D shape that could inherit from rectangle is square. Both rectangle and square have length and width. So maybe a member that square has that rectangle doesn't have is maybe a member function that sets length equal to width, because length and width have to be the same in the square. And then after that, we would logically have cube inherit from square, because cube has length and width, but one variable that cube has that square doesn't is height. And then we'd probably add like other variables like surface area and volume too to cube. And then obviously we'd also have the shape pyramid inherit from triangle, which pyramid could have volume, surface area, so on and so forth. You get the idea, right? But you know, like, imagine you really were asked to write a class called like circle or square, and then write a derived class from it that called sphere and cube, and that has all those exact same variables, but it has a couple more added to it. In fact, I think that would be a pretty good question on the final to ask. Maybe I'll consider it. Anyways, the second diagram, this is exactly what we were doing before. We have person type, which contains first name, last name, age. We got student type, faculty type, which I already discussed, and then employee type, master student type. This is what the hierarchy tree would look like if we were just to continue this and make our program bigger. I think you get the point, right? So anyways, those are just a couple examples that I just pulled from my head, because, you know, I've been programming for a while. But you'd probably want to see an example of inheritance that's like comes from real life, like not an example that I pulled from my head. So in case you didn't know, I'm using whatever free time I have to teach myself how to code in Swift. Now, in case you didn't know, Swift is a programming language that you use to write apps in on the iPhone. Now, this is one of many libraries that Swift has. Like, I as a matter of fact, I think I pulled this diagram from Swift's UI kit library, which is a user interface and library. Anyways, so as you can see in this diagram, I think I need to make this bigger for you. Let me do this. So in this diagram here, there is a base class called NSObject, and then all of these classes here inherit from NSObject. Now, how many classes is this? This is a lot, like 20 or 30. And then these classes inherit from these, and then these classes inherit from this. Now imagine, like, if you were writing a large program one day, like, if you were using inheritance to write your classes, you could literally save yourself thousands of hours of time, thousands of hours of manpower, okay? Just for the sake of writing those really, really large programs, you know? And if you're working as a software developer for a company one day, that is exactly what you're gonna do. Okay? So, inheritance is super, super powerful. That's... actually, that's an understatement. Like, inheritance, like, it's very invaluable to... It's a very invaluable tool for the C++ programmer, okay? So, now that you know what inheritance is, it's time to... Well, it's almost time to start applying that to our program, okay? So, to write a derived class, that is a class that inherits from a base class, the syntax is shown in this gray box, okay? So we have the keyword class and then class name, which is the new class that we're writing. And then we have a key term called the member access specifier, and then the base class name, which is the class that we're inheriting from, okay? Now, to inherit from a class, it's very simple. You just put colon, and then this word, and then this word. So you know what this is, but I didn't go over what member access specifier is. So the member access specifier could either be the word public or private, which is two words you already know, or the word protected, which is a key term that I actually didn't teach to you yet. So if you actually went back to the class lecture video, you already know what public and private mean, right? So public variables are, they can be accessed at anywhere, but private variables cannot. As for protected variables, protected variables, they're exactly like private variables. They cannot be accessed outside of the class unless you use like functions that are inside of the class. But the difference between private and protected variables is that they can be accessed by a class that's deriving from it. Okay? This would make better sense later. And over here is a brief little, like, I guess a list that briefly talks about why it's important that you choose a specific member access specifier, either public, protected, or private. If you set member access specifier to public members of A, which is the base class, are public members of B, which is the derived class. Protected members of A are protected members of B, and private members of A cannot be accessed in B, okay? If you set this to protected, public members of A are protected members of B. Protected members of A are protected members of B. And private members of A cannot be accessed in B except by member functions in B. And if you set it to private, public members of A become private members of B. Protected members of A become private members of B. And private members of A cannot be accessed in B except by member functions of B. Okay, I'll tell you the truth. I pulled this table from my old C++ textbook, and I decided to show it to you because I guess it's important, but the truth is, when I'm coding, I don't remember this. I always set member access specifier to public, and then I go to the base class and change the word, the key term private to protected. That's all I do. I don't remember this, and I don't expect you to either. Okay, but anyways, I just thought I'd share this with you because I would like for this course to be somewhat comprehensive. Because I don't want to cheat you from information that you should know when you're working as software engineers one day. Anyways, okay, now we can go down to the lecture activity. Now, you're probably all itching to use inheritance now, right? So we will write a class called student type that inherits from person type, okay? Then we will write 3 private members called string SID, string major, and double GPA. Then write setter and getter functions for each. Note, you do not need to rewrite first name, last name, and age because they are inherited from person type, okay? And as for this last note, I actually said this before. I'm going to change the key term private to protected. Okay? So let's go back to let's open Visual Studio and get started on this. Okay, so this will be saved over, oh, not there, here. So I'll select this folder. We will call this lecture activity 7. Create. Cool. So let's make our main.cpp. Let's make this larger. Include our typical C++ jargon. Include IOStream using namespace standard int main return 0. So I think the first thing we have to do is get our person type.h in here, okay? So in order to do that, let's reopen our lecture activity 6 and get that file, okay? So lecture activity 6 is actually the thing that's due tonight, so I hope you did it already. So yeah. I'm gonna go here to lecture activity 6. I'll open it. Well, just for a brief moment. Because so yeah, this is lecture activity 6. Now, the reason why I wanted to open this is because there was actually one thing that I wanted to do in lecture activity 6 that I completely forgot to do in the last lecture video, and that was the same way that we condensed these lines of code using constructors. I would like for us to condense these lines of code using the constructors that we wrote here. Yeah, my bad. I completely forgot to do that. So, well, you don't have to do this. I'm just showing you to do this because many of you already turned in lecture activity 6. So person type person A, we will pass Jane Doe and 25. You don't actually have to do this to your lecture activity 6 because you already turned it in. I'm just showing it to you. Then this line of code can take the place of these lines of code. I wonder why it's not showing colors. Oh well. Do the same thing for this. Person type person B John Doe 20, and then this line of code can take the place of these 4 lines of code, and then person type C Lawrence Orijuela 25. Okay. And then this can take the place of these. Save it, run it. Oh, my bad. Yeah. I meant to condense this before, but I completely forgot to do it. Anyways, so do that if you want to. You don't have to if you already turned in lecture activity 6. But anyways, we need our person type.h. So the easy way to get this is to actually, let's close this. Go into the lecture activity 6 project folder. Find your person type.h file. Copy that. Go to your folder that has lecture activity 7. Go into its project folder, and then paste person type.h. So now person type.h is the copy of the file is now in our lecture activity 7. And now what I'd like you to do is on source files, right click it, hover over add, click existing item, and select person type.h. And then open that. To make it just easier to see, dock this over here. So here's our main.cpp, here's our person type.h, okay? And it has everything that we did before. 3 private members, 3 setter functions, 3 getter functions, a print function, and 3 constructors, okay? So we are writing a class called student type that inherits from person type, okay? Now, you already know what student type needs to contain. It needs to contain everything that person type contains, including 3 new variables called SID, major, and GPA, okay? Now, before we actually do this, we need to do something important, and that's go back to person type and change the key term private to protected so that inheriting classes can use those variables, okay? So, here in our class person type, we had 2 keywords. This keyword that says public and this keyword that says private. Take this keyword private and change it to protected, okay? Just like that. Now, the only difference that this makes is that first name, last name, and age, they're still private, but they can be accessed by classes that are inheriting person type, okay? So now that we have that, let's make a brand new header file. Right click source files, hover over add, click new item, choose header file and call it studenttype.h. Add. Awesome. So I'm gonna dock studenttype.h over here, I guess. And our main.cpp and our persontype.h, they're kind of getting switched, but that's okay. So studenttype.h, okay? So you already know the purpose of the pragma once. It's to prevent multiple libraries from being added to the same thing. So keep that pragma once here if you're using Visual Studio. And so in order to write a new class called studenttype.h, we actually need to include the class that we're inheriting from, and that's persontype.h. So I'm going to say include, and in double quotes, I'll say persontype.h. Okay, like that. Awesome. Now I can start writing my studenttype.h, and you know the syntax. It's right here. Class name, which is going to be student type. Member access specifier. I'm just going to use public because that's what I always use. And the class and the base class name, which is person type. So class student type colon public. Now keep in mind, public is the thing that I was saying before. It's my member access specifier. And by setting it equal to public, oops, that's not it. Where's that table I made? Oh, by setting it equal to public, public members of person type will become public members of student type. Protected members of person type will become protected members of student type, and then private members of person type cannot be accessed by student type. And that's all that means. Okay, and I'm gonna say the base class is person type, so, and then squiggly brackets. Oops, everything's going wrong today. So I'm going to use the same keywords that I used before for writing classes. One's going to be called public, like that. The other one's called private, like that. Okay. Now, if you recall before in the PowerPoint, student type requires 6 variables: first name, last name, age, SID, major, and GPA. But here's the thing. By putting this here, every member of person type is copied by the compiler and added to student type. And this is all done behind the scenes thanks to this line here. You don't see it yet because I didn't run it, but that's actually what's happening behind the scenes, okay? So I actually don't need to write first name, last name, and age and their setter and getter functions again. I just need to write SID, major, and GPA, okay? So maybe I'll put a comment there. So I'm gonna say first name, last name, and age are inherited. No need to write them again. Okay. But I do need string SID, which is your student ID. Well, we could have had this be a number, but I thought it best to make it a string. And then we're going to have a string called major. And then we're going to have a double called GPA. Okay? So here are our private members of class student type. Now, the second thing we need to do is write setter and getter functions for SID, major, and GPA. Okay? So go over here to public. Give yourself a little space. We're going to make setter functions. Setter functions are always void. Remember that. And they're going to be called void set SID. It'll accept a string because that's what SID is. Void set major. It'll accept a string because that's what major is. And then we're going to have another void called set GPA. And it's going to accept a double. Okay? So here are the function prototypes for our setter functions. Okay? Now to write the getter functions. Now, getter functions, because they retrieve the private members, they have to be of the same type of what it's corresponding to. So I'm going to say string get SID. Remember, getter functions don't accept parameters. They just return something. String get major, like that, and then double get GPA. Now make sure you remember the process on how to write a class, because you will be asked to write a class for your final exam. Okay, so here are setter and getter functions. Now let's write the function definitions. So I'm going to copy these. Copy. Scroll down here. I'm going to paste it, and we can start writing. We can convert these into definitions. So get rid of this comment, get rid of this comment, delete these semicolons. Add squiggly brackets. Oops. Here, here, and here. And for these in particular, we have to give these variable names. So I'm going to call it S1. Well, actually, no, I'll just call it S. Call it S. Call it D. And then, per usual, set SID will accept a string and set SID equal to it. It's not. Oh. One thing I forgot to do. Because these are member variables of... These are member functions of this class, I have to put student type : in front of all these. So I'm going to say student type : okay? The only thing that this does is indicates that this this function is a member of this class, okay? So take this, copy this here, 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 and here, and here, okay? So SID equals S, major equals S, GPA equals D. Okay? Now for our getter functions, they're very simple. So get SID, we'll just say return SID. Return major. And then return GPA. Yeah, it's really easy to write setter and getter functions. Okay. Okay. So I'm gonna zoom out so you can get a good look at it. Here's what it looks like so far. Okay. What else do we need to do? You do not need to write. Okay. So that was actually the first step into writing our student type student.h. I feel like I should do something. Maybe I should go back to the main.cpp and say that. Yeah, I'll do that. Actually, I'll close persontype.h for now, and then we can... Did I make changes? Oh yeah, I changed it to protected, yeah. I'm going to close persontype.h for now, and then I can just reopen it when I need to refer to it again. So, I guess I'll start couting some things. So cout, even though this is, you won't see this because it's written in student-type.h, I'm just going to put sections like we normally did in the previous lecture activities. This is part A. Student type. Yeah. It's part A. Student type member. Well, let's call it private members. Yeah. Handline. And then I guess I'll put a comment here saying on student type.h, just so we remember. So that's part A. Part A was just all this. Okay. We did this. Okay. So if you recall from classes before, So here's a good question. How do we use inherited member functions? Okay. So member functions of derived classes can call the member functions of the base class. This is done using the scope resolution operator, which is : : okay? You'll see when we use this. Now, observe that the class person type contains a member function called print, okay? A lecture activity part B says write a print function for student type that calls the print function of person type, then couts SID, major, and GPA, okay? So I guess we'll call this part B cout. This is part B. Student type print function. I guess I'll call it that. Yeah, that works. And I'm gonna put another comment here. It's also called on student type h. Well, the reason I'm doing this is because I'd like it if one day, maybe when you're doing your other classes for computer science, maybe you could keep your lecture activities and refer to them in case you want to like consult like previous work on how to do stuff. So I'm gonna go back here to my person type.h. I'll dock student type.h over here. Recall that there's a that person type.h has a print function, which means that student type has this print function too. Okay. Now, this print function, however, refers to the class person type, and if you scroll down here to the function definition, so person type print, and this is this double colon here. This is the scope resolution operator I'm talking about. It has the function definition here where it says first name, last name, age. We would like to do this, but for student type. Okay? Now, because this is inherited, we actually don't need to write this code again. Here's a cool feature that you can do with inheritance so that you can get this print function and write a new print function for student type.h that appends to it. So here's what I'd like you to do. Here in public, add a new comment called other functions, and let's call it void print. Okay. So scroll to the bottom, make a new function definition, void student type colon print. We need to write the definition. So because this is here, we actually don't need to write this again. One thing that we can do is call the print function of person type, and the way we do that is using the scope resolution operator. And the way you do that is by saying person type colon print. Okay. Now what this does is it calls the print function from class person type, which is actually here. So when the compiler reaches this line, when it goes here, it'll see this and it'll jump to the person type.h class and call this function. So having this here is actually the same as having these lines of code in its place. Okay? So this covers first name, last name, and age. All we need to do now is state SID, major, and GPA. Okay? So the way I want you to visualize this is imagine this is taking the place of this one line of code. Okay? And then we're just picking up from here. Okay? So start a new line, say cout SID. So SID that SID and line cout major major should be capitalized. And line cout lastly age, or no, not age, my bad, GPA. That's right. GPA. Like that. Let me see something. Okay. So this is the print function for student type. So you can see two save buttons on the ribbon here, right? One is this single save button. The other one is this two save buttons stacked on top of each other. So this save button saves the file that your pointer is currently on, right? This double save button saves all the files. I just thought I'd share that with you because we're working with multiple files now. So, so yeah, this finalizes the print function for student type. What else? So that's lecture activity B, where it calls the print function of person type and then couts the remaining other variables. Okay. And that's how you use inherited member functions using the scope resolution operator. In other words, this. In fact, maybe I should add a comment here. Calls the print function of person type. Just so that you know for future reference. Okay. What else do we have to do? Alright, so the other thing that you need to know, aside from using inherited member functions, is how to use inherited constructors. Now, when it comes to inheriting constructors, it's a bit tricky. Well, it's not really tricky, but it's just not intuitive. You'll see what I mean. So, as with constructors, as always, it is good programming practice to write a default constructor before parameter constructors, okay? And if you recall from the previous lecture activity, default constructors accept no parameters. Parameter constructors do accept parameters, okay? The constructors of the derived class can also call the constructors of the base class. You can call the constructor you wish from the base class using colon and then base class constructor and then parentheses. You could have it be empty or you could have it contain parameters, okay? And then you add this to the end of the function definition of the derived class, okay? This will make more sense when we do it in lecture activity, right? See? So here in part C, we will write a default constructor for student type that calls the default constructor of person type. And then we will do the same thing. We will write a parameter constructor for student type that calls a parameter constructor for person type. Okay? So inheritance, even though it's powerful, it has like little nuances that you need to know. But we'll get through it. So the next thing we have to do, we inherited all of these. Now we need to inherit the constructors. And as always, there is a default constructor and a parameter constructor, okay? So go back here to public. Make a new comment that says constructors. And write default constructor here. This is where we'll write it. And then parameter constructor here, okay? So as always, you already know the syntax for writing a constructor, unless you need me to pull up the previous PowerPoint from last week. So these are for structs. So for classes, you just put the class name, empty parentheses, and for the definition, you put class name : and then the definition. Okay, so I'm going to say person type. Oh, no, not person type. Student type. Like that. So that's the prototype for the default constructor. Let's copy this, scroll down here, and write its definition, okay? The definition is this, where we just put, you know, class name, : class name, with empty parentheses, okay? So get rid of the semicolon and add student type : again. All this is the scope operator again. And all this indicates is that this constructor is a member of student type. That's all that means, okay? So, here's what we're going to do. We need squiggly brackets. Like that. And now, if you want to call the default constructor of person type, like if you look over here, here's the default constructor for person type, and its definition is actually down here. We actually set first name equal to NA, last name equal to NA, and then age equal to -1. We can continue that same trend here. Now, there's actually two ways in which you can call this. The first way is the same way we did before, where we say, oops, where we do something similar like we did in line 65, and just use the scope operator to call this function, okay? So I'm going to say person type : and then the person type constructor. Like that. So what this line of code does is that it calls the default constructor of person type. Like that. Okay? And then we can write the default variables for our new private members, which is SID, major, and GPA. Now I'm gonna pick up where we left off. I'm gonna set set SID equal to, well, let's be consistent and put NA again, since the default constructor accepts no parameters, n/a. And then for major, I guess if you don't have a major yet, you would say undeclared, so let's use that. And then as for GPA, I guess it would be 0. So here is the default constructor for student type. Now, I said you can do it like this, but the way that I like to do it is I would actually, instead of using this, what I do is put a single colon here and say person type. Like that. I wonder what this warning's about. So, you could do it this way or you could do it this way, but either way, doing it like this or doing it like this calls the default constructor of person type. Okay? I hope this is all making sense. But, yeah. So, actually, I'm going to delete this comment because I'm always going to prefer to do it like this. So, this is how you call the constructors of base classes, okay? And then lastly, since we finished writing the default constructor, which is this, we need to write the parameter constructor for student type. That's a little more trickier, okay? So here on student type, go back to your public area and write the parameter constructor for student type. Now, the variables that's going to get passed into student type, because it's first name, last name, age, and then SID, major, and GPA, it's going to be string, string int, string, string double, okay? So that's going to be the parameter list of the parameter constructor. So over here, I'm going to say student type string int string double. Okay, so copy this parameter constructor. Let's write the definition for this. Scroll to the bottom, paste it here, put student type : in front of it again, because this indicates that it's part of this class. Delete this semicolon, add squiggly brackets, and now we need to assign names to these variables. Now, because these variables here are inherited from person type, and is good to be consistent, we should give them the same names. So the parameter constructor calls them S1, S2, and I. We should be consistent and call them S1, S2, I. All right, S1, S2, I. And as for the other strings, I guess I'll call them S3, S4, and for the double, I'll call it D. Okay. So now I have to write the definition. So we want to call the parameter constructor for person type, and that's actually this. So we're going to do the same thing we did for the default constructor and just put colon and then the function, and then call the function there. So I'm going to copy this, okay? Copy that, go over here. At the end of this big thing, I want you to put a single colon and then paste it. Okay? Yeah, that's what you do. I wonder why this is an error though. Oh. One thing I forgot to note is that when you call the constructor, you actually don't need to say the data variables again. So delete this string, delete this string, delete this int, because the data types are already specified here and there's actually no need to specify them again. But that's actually how you call the constructor of the base class, using single colon and then base class constructor. So by having this here, this constructor calls the constructor of person type and sets first name equal to SI, last name equal to S2, age equal to I. So the last things we need to do is set S3 equal to SID, S4 equal to major, and D equal to GPA. So let's do that. So SID equals S3, major equals S4, and GPA equals D. Okay. Because remember, having this here is equivalent to having these lines of code in front of like having it right here in the beginning before it can performs these lines of code. And I really hope this is all making sense, because since we're inheriting from person type, there's actually no need to rewrite this code. Okay? So that's what inheritance is. Right. These are all parts of this now. Okay? So I should actually write that in the main.cpp as well, that we completed part C, which is the constructors. So I'm going to go to main.cpp and say cout C student type parameter, just call it constructors. Like that. And I put another comment that says on student type dot h. Okay? So, we've done lecture activities part A, B, and C now. Okay, so at this point in time, our student type.h is ready to use. Now, let's take a quick moment to recall everything that we did. So, yeah, it gets a little hard to manage sometimes when you have multiple files, but it's okay. So, because student type is inheriting from person type, everything that's in here, the compiler copies all of this and pastes it into student type, but you don't see it here because it's done like behind the scenes, okay? So, student type already has first name, last name, and age, and setter functions, and a print function, and a default constructor, and other constructors, okay? What we added to student type that person type didn't already have were SID, major, and GPA. It set the setter and getter functions for all those three respectively, a brand new print function that prints everything, and then a default constructor and a parameter constructor, okay? This print function, if you go down here, it calls the print function of the class that we inherited from, which is this. And then we printed the remainder. And then we call for the default constructor and the parameter constructor. We had the default constructor of student type call the default constructor of person type. So having this here was the same as having these three lines of code execute before these lines of code. Well, my bad. These before these. Okay? And then lastly is the parameter constructor, which accepts 6 variables because student type has 6 variables. First name, last name, age, SID, major, and GPA. Okay. It takes six variables, and by having this colon and then calling the default parameter of person type, we set S1 equal to, we set first name equal to S1, last name to equal to S2, and then age equal to I. And then as for the remaining variables, we set SID equal to S3, major equal to S4, and GPA equal to D. Okay? So this student type .h class is now ready to use. Okay? So here's what I want you to do. We can do that later, but let's do lecture activity G, H, and I, and we can do D, E, F, and J, K, L later. So I'm going to I'm going to move around because I want to demonstrate student type already, okay? So let's do lecture activities part G, H, and I now, where we use student type and invoke the default constructor, use student type, invoke the parameter constructor, and then create a vector of student types and push student 1 and student 2 to it, okay? So over here on the main.cpp, it's time to start using this. So I'm going to say cout. This is parts. I'm going to close those. G. Create an instance of student type called student1 that invokes the default constructor. And then pass no parameter to it, and then call the print function. Okay? So this is part G. Student type invoking the default constructor. Like that. And then say student type student 1. Okay? Because we have to include the reason why this is an error because we have to include person type and student type. My bad. So go to the top and include person type.h, include student type.h, like that. Okay, so this should stop being an error. Okay, great. Now because there's no parentheses here, we didn't pass any variables to it, and because of that, this actually invokes student type's default constructor, which calls the default constructor of person type. So it actually, what ends up happening is that this code executes first, and then this code executes next. All because this bit is here, okay? And I can prove that to you if I call the print function for student 1. So student1 dot print. So student 1's print function looks exactly the same as student 1's print function. It calls the print function of person type, which is here. It does these lines of code first, and then it does these lines of code. So what should happen as a result of me saying student1.print is that it'll output first name, equals NA, last name equals NA, age equals -1, and then SID equals NA, major equals undeclared, and then GPA equals 0. And I can demonstrate that if I just run this. Okay, so do we see what happened here? It's doing exactly what we thought it would do. Okay? So this happened first, which is here. And then, God, this happened next. Oh, this happened next. My bad. So, yeah, I'm sorry, guys. This is not my smoothest lecture, okay? But I really hope this is making sense to you guys, like how inheritance works. But anyways, we need to move on to lecture activity part H, which is create an instance of student type called student2 that invokes the parameter constructor, pass variables for first name, last name, age, SID, major, and GPA to it. So, what I'd like you to do is end the line here, and then say cout. This is part H, because I'm jumping around. Call this student type invoking the parameter constructor. Like that. And then make a new student type and call it student2. Student2. And in parentheses, we have to pass 6 variables to it, okay? Those variables are going to be called S1, S2, I, S3, S4, and double, okay? So let's make a new student here. We need to say first name, last name, age, then SID, major, and then GPA. So I guess I make up a student here just with that data. So I guess for the sake of example, I'm going to use myself because I'm a student. I'm going to say Lawrence for the first name, Orijuela for my second name. My age is 25. And then my SID, it has to be a string, okay? So don't put your real SID, just make up a number. And then my major is computer science. And then my GPA is actually 3.84. So by having parentheses here, this actually invokes the parameter constructor for student type.h. And the way that works is that the parameter constructor of the base class is invoked, then it does these. Okay? So what should happen as a result of me doing this is that if I take student2 and use the print function, we should see all this information loaded into student2. Yep. First name Lawrence, last name Orijuela, age 25, SID is this. Major is computer science, GPA is that. Okay, great. And then for lecture activity parts I, we need to push student 1 and student 2 to a vector of student type. Okay? So I'm going to cout and a line here. Cout. This is part I. Call it vector of student type. Okay? And to do this, we have to include vector. So go up to the top and include vector. Like that. And now create a new vector of type student type and call it, let's just call it students. Okay. So we're going to take students and say dot pushback student 1, and then students dot push back student 2. Okay. And I guess I'll just end a line again. Okay, great. So let's run this one more time, see how it looks. Okay, so that's parts A, B, C, G, H, and I. We have to go back and do the other parts of the lecture activity because I kind of jumped around a bit. Yeah, I know. I'm really sorry about this, guys, but I have a feeling that this is going to be another very long lecture video. So here's what I'm actually going to do. So student type.h, I'm going to like I'm going to scroll down really slowly so you can get all of this. Now, I hope you understand how inheritance works. I hope you understand how this works, how this and this works. The reason why we don't have to say first name, last name, and age again, because they're all inherited thanks to this. Okay? So, that's how you write the class student type inheriting from person type. Okay? Now, because these lecture activities are starting to get really, really long now, I might make lecture activities 6, 7, and 8 worth more points than normal, because I know that this is a lot to digest. But anyways, I'm sorry to do this to you guys, but it's actually time to create a brand new class called faculty type that inherits from person type. Like, do you see this diagram here? We're actually doing this. We already did this, now we have to do this, and I have a feeling that this is going to take another hour. So, pause the video, grab a cup of coffee or something, and then come back to this, okay? But anyways, it's time to continue. So we did lecture activity parts A, B, and C already. Now we're repeating the same thing that we did for faculty type.h. So write a class called faculty type that inherits from person type. Then write 2 new private members called discipline and salary, and then write setter and getter functions for each. And then E says write a print function for faculty type that calls the print function of person type, then see out to discipline and salary. And then part F, write a default constructor for person type that calls the default constructor of person type, and then write a parameter constructor for faculty type that calls the parameter constructor for person type. Okay, so this is basically doing everything that we did for student type, just for faculty type. Okay. Now I hope that this isn't too hard. I'm actually going to close student type.h because we actually don't need this anymore. So what I'd like you to do is right-click source files, hover over add, click new item, and call it, select header file and call it faculty type.h. This will all be worth it in the end, I promise, guys. So I'm going to dock this over here. First and foremost, because faculty.h is inheriting from person type.h, we need to include person type.h. Nobody said that being a computer programmer is easy, right? So using space standard. Now you already know the syntax to make a derived class, okay? It's already over here where you say class name, member access specifier, which is going to be public and then the base class name. So I'm going to say class, I'm going to declare a new class called faculty type, colon, public, person type, like that. Squiggly brackets have a section called public, and then a section called private. Just like that, okay? Now, because faculty type is inheriting from person type, we actually don't need to say first name, last name, and age again, or write the setter and getter functions, but we do need to include two new variables, both of them being discipline and salary. So under private, create a string called discipline, and then a double called salary, and then we gotta write setter and getter functions for discipline and salary. Okay, setter functions. As usual, setter functions are always void, so void set discipline. It needs to accept a string, and then void set salary, which needs to accept a double. And then the getter functions, I'm doing this faster this time because we kind of did this already for student type. The getter functions, they need to be string get discipline, empty parentheses as typical, and then double get salary. Like that. So these are the prototypes for the setter and getter functions. Let's define them. Copy this, put it on the bottom here, put faculty type colon in front of these, colon. Copy this, put it here, here, delete these comments, delete the semicolons, add squiggly brackets. Like that. And as for the setter functions, we need to give these names. So it's string, I guess I'll call you S. This double, I guess I'll call you D. So discipline will be equal to S. Salary will be equal to D. I get discipline, we will return discipline, and then we will return salary. So the setter and getter functions have just been written. Okay. So this was lecture activity part D. Go back to your main.cpp and see out another section called D, E, and F. So D, faculty type, call it private members. Put a comment that says on faculty type dot H. So part D is done. We actually did it here. Now for part E, write a print function for faculty type that calls the print function of person type. Then see out some discipline. and salary, okay? So, person type, the print function is here. Its prototype is, or its definition is this, so first name, last name, age. So we actually need to go to our faculty type, put a comment that says print function, and then say void print, like that. And then copy this, go to the bottom, and let's write the print function. We need faculty type : : in front of it as per usual. Delete the semicolon, add squiggly brackets, okay? So we need this print function to call the print function of the base class. So I'm going to say person type : print. Having this line of code here is the same as having these 3 lines of code in its place. So first name, last name, age is done. And now I need to repeat the same structure for discipline and salary. So I'm going to go over here and say cout hyphen discipline discipline and line, and then cout salary. Salary and line, like that. Okay? So that's the print function. The print function is done. So that was part E. Go back here and go to your main.cpp and say that cout part E faculty type print function and line. Comment on faculty type .h, like that. So part E is done. Now we got to do part F. Write a default constructor for faculty type that calls the default constructor of person type, and then write a parameter constructor for faculty type that calls the parameter constructor for person type. Okay, so you already know how to do this. Put a comment on the top saying constructors default constructor. You already know the syntax is just the class name, empty parentheses. So faculty type, like that. Take this, copy this, scroll to the bottom, print it, put faculty : in front of it, like that. Delete the semicolon, add squiggly brackets, okay? So we need to call the default constructor of person type, and the way we do that is we put a colon here, and then go to person type and put and call the default constructor, which is person type empty parentheses, like that. Okay, so as you know, this bit of code here invokes is the same as having these 3 lines of code execute before anything in here. So because this is the default constructor and it accepts no parameters, we have to set discipline and salary equal to something. So I guess we'll set discipline equal to, just to be consistent, let's put NA again, n/a. And then for salary, I guess we'll put 0. 0, like that. Okay, so that's the default constructor. Go ahead and save everything. And now we need to write the parameter constructor. Parameter constructor. So faculty type, we need to pass 5 things to it. It needs to be string, string int, and then string double. So string, string, int, string, double. Like that. So copy this, scroll to the bottom, put faculty type colon colon in front of it to indicate that this is a member of faculty type .h. We need to delete the semicolon, add squiggly brackets. We need to give these variables names, and they have to match the parameter constructor of person type. So it has to be S1, S2, and then I. So name them S1, S2, and then I. And to be consistent, I guess we'll call the third string S3, and then the double D. And then we have to invoke this constructor, we have to put colon this in front of it. So I'm going to copy this where it's string, string, I. Put a colon here and then paste. This calls this constructor, but as per usual, we need to delete these data types because we already stated them before and there's no need to state them again. Yeah, we stated them here, here, and here. And by having this bit of code here, this actually calls the constructor of this thing. Okay? It sets first name equal to S1, last name equal to S2, and age equal to I, but we need to do the 2 remaining parts, which is discipline and salary. So we need to set discipline equal to S3, and then salary equal to D equals D, like that. So that is the print function for faculty type. Go back to your main.cpp. Wow. And make a new section called F. Cout part F faculty type and call it constructors. Like that. And put another comment that says on for faculty type.h. Like that. So we did D, we did E, and now it's time to do part F. Oh wait, we did F, my bad. So it looks like all that's left is to do lecture activities part J, K, and L. So create an instance of faculty type called faculty1 that invokes the default constructor, pass no parameters, and then call the print function for it. So this is part J. So cout, this is part J, faculty type default constructor, invoking the default constructor. So faculty type invoking the default constructor, like that. And then create a new variable of faculty type called faculty1, pass no parameters to it. So faculty type faculty1, leave it as is. Oh, my bad. Because this is here now, I have to include faculty type. Include faculty type .h, like that. Okay, great. Now this is no longer an error. And then I'll say faculty1.print, which calls the print function of faculty type, which is here. And by doing this, because there's no parameters, this invokes the default constructor. Which is this and this. So we should find that this code's executed in this. So first name will be NA, last name will be NA, age will be -1, discipline will be NA, and salary will be 0. So if we actually printed that, we should find that. And that's exactly what we see. First name is NA, last name is NA, age is -1, discipline is NA, and salary is 0. And then lastly, we have to invoke the parameter constructor. So I'm going to go over here to my main.cpp. I'm going to say cout and line j. This is part K, where we have to invoke the parameter constructor. So faculty type faculty 2. We need to pass 5 parameters to it, and that's gonna be string, string int, string double. Okay, so you included yourself in this student type. For this faculty type 2, since we're invoking the parameter constructor, I guess the values you can put in. Why don't you put in the values of me, since I'm a professor. Okay, so we have to say first name first. So put my first name, Lawrence Orijuela, and then my age is 25. My discipline is computer science, like that. And then lastly, my salary. I'm not gonna put my real salary. I'll just put $100,000. That's not my real salary, but yeah. I don't think I'm allowed to tell people how much I'm getting paid. But anyways, this faculty 2 invokes the parameter constructor, which is this. The parameter constructor faculty type invokes the parameter constructor person type, which is here. I'm sorry. And which is here. And then it does these 2 lines. So we should find as a result that this sets first name equal to Lawrence, last name equal to Orijuela, age equal to 25, discipline equal to computer science, and salary equal to 100,000. So what we should do next is say faculty 2 and call the print function for it, and then cout and line. Okay, so save that. Let's run this and see if it works. Yep, it works. Lawrence Orijuela 25, computer science 100,000. Okay, great. Alright, so that's lecture activity part J. Last is lecture activity part K. Push faculty 1 and faculty 2 to a vector of faculty type. Okay? So let's create a new vector. We're going to say vector faculty type. And let's just call it faculty. Faculty dot pushback faculty 1, and then faculty dot push back faculty like that. And as per usual, we need to cut this into sections. So on this line here, say cout. This is part K. And we're going to call this vector of faculty type. Like that. Okay. There you go. Save it, run it again. Okay. So that's everything. So now you know how to inherit from a base class. Okay? So let's do a brief recap of everything that we did. So open. I'll put student type. I'll put faculty type here and student type over here, I guess. So we can see everything. So student type and faculty type both inherit from person type, okay? It contains first name, last name, and age. Because it's inheriting, we actually didn't need to state first name, last name, age again for both of them because it's inherited, okay? So what we did was we created setter and getter functions for student type called SID, major, and GPA. We did that, and we created setter and getter functions for discipline and salary for faculty type when we did that, okay? The other thing that we did is that we inherited the print function from person type, and then we inherited the constructors from person type. Okay, so that created a. So as a result, we have 2 derived classes and 1 base class. And having a base class actually saved us time, okay? Because we didn't have to restate these definitions again. Does that make sense? So now you know the power of inheritance. Now, I know this is a very long video, and I know this is very long-winded, but yeah, so this is everything that I wanted to cover in inheritance, and I know this is not my best work, okay, but you know, I'm trying here. This is my first time teaching this class. So yeah, so here's what I'm gonna do now. I'm going to open everything. So the first thing I'll do, here's my main.cpp. You can see it's very brief because most of our code is in the header files, right? I'm gonna make it large. Here's a bunch of includes. I'm gonna scroll down really slowly so you can get everything. Hopefully that there's nothing that you missed. Now I'll open person type.h. I'll scroll down really slowly to make sure that you got everything. Now I'll open student type.h. I'll scroll down really slowly to make sure that you get everything. And then I'll open faculty type.h. And I'll scroll down really slowly to make sure you got everything. This video is already budging 2 hours. Like, I'm sorry to put you guys through this, but I needed to demonstrate what inheritance is. And this was actually, when I was preparing these lessons over the summer, this was actually the shortest, like, this is the simplest example I can think of how to introduce inheritance to you guys. And I actually can't think of a simpler way. So, when you're ready to turn this in, here's what you'll do. So run this one more time. Get a screenshot of this. And then go to your email. Send it to me, 005823892@coyote.csc.edu. You already know the use. CSE2000Q2S, last name, first name, act. What act number is this? Is it 7? I'm sorry, guys. I'm tired. Yeah, let me see. Yeah, this is Act 7. Act 7. Put the screenshot here in the body. And then I actually need, in order to get credit for this, you need to submit 5 things to me. The first one is a screenshot, okay? Next is your main.cpp, then your persontype.h, then your studenttype.h, and then your facultytype.h. You need to send all of those, okay? So click the clipboard thing, go to your lecture activity 7, go to the project folder, select facultytype.h, main.cpp, persontype.h, and studenttype.h. Open all 4 of these, and then send it to me, and I'll give you a grade. Now, because of how massive this actually became, I might consider giving you more credit than this is actually worth, just as a reward for just doing this. So yeah, I'm sorry to be overloading you with this much work, but we have to get through this because we need to get through everything that I said we would go through in our syllabus, classes, inheritance, and then next week we're gonna talk about overloading, like operator overloading, where we write the overload functions for studenttype.h and facultytype.h. So yeah, a lot of work. I'm sure this is all keeping you busy. It's keeping me busy too. It actually took a very long while to showcase all of this, because all these diagrams I made myself. All of these slides I made myself. Okay, but anyways, that's it for this lecture video. I hope this was very fruitful. I hope you learned a lot about inheritance. So anyways, I'm going to wrap it up and go to bed now because it's 2 a.m. And yeah, turn this activity in before midnight of next week. And make sure you turn in your activity 6 and your midterm before midnight tonight. Anyways, thank you for sticking around this long, and I will see you next week.